For this lesson, this is called Lesson 18, Overcoming a Second Obstacle in Factoring, What to Do if There is a Remainder. So in other words, we're going to go back to reverse tabular method and long division. We're going to investigate this process. Only in this case, we're going to have remainders. Whereas last time we looked at this, we did not have a remainder. So many of the techniques that I'm going to show is going to be the same. We're going to skip the opening exercise. And we're going to go to example 1. I'm all in example 1. I'm going to skip part A, and we're going to focus on part B. Mainly in this lesson, I'm going to talk about reverse tabular method and long division. It's just in this case, we're going to have remainders at the end of each process. So the first method that I will highlight will be the reverse tabular method. And in many ways this is going to work exactly the same way. So we need to figure out how many rows and columns we have. So for rows, remember we have to take whatever exponent is here and add 1. So that means I'm going to have 2 rows. And then for my columns, right, I have to subtract this exponent minus this exponent. So 2 minus 1 is 1. And then I add 1 to that result. And so I'm going to end up with 2 columns. So we'll draw our box. Like so, we're going to have 2 rows and 2 columns. And then we're just going to put our information on the side. So our divisor goes here on the side. We put our dividend around the edge. So that becomes x squared plus 3x and then plus 5. Now in this case you do have to be more careful. We're not going to use this box at all. This is going to be the last box we're going to go to. So we start by plugging in our x squared. And so when we plug in x squared divided by x is x. And then x times 2x. X times x is 2x. We have to add this box plus something to get 3x, so we need a 1x right here. So 1x times x, or 1x divided by x, is plus 1. Now, here's where it gets interesting, right? 1 times 2 is 2. But it says I'm supposed to have a 5 there. It's not that we did anything wrong, we actually have a remainder. So we're going to take this 5, and here's what's different. We're going to set it equal to 2 plus, let's just call it an r. And so I solve this one-step equation, and I find out that r is equal to 3. So that means if I divide these together, my answer is x plus 1 with a remainder of 3 over, and I use my divisor, x plus 2. So this is the reverse tabular method. Let's compare it to the long division way, right? So if we say long division, that means we would write our divisor x plus 2, our bar, and then x squared plus 3x plus 5. And we're going to divide, so x goes into x squared, x times. So we distribute, you get x squared plus 2x. Make sure you put your parentheses in your line. These go to 0, and 3 minus 2 is 1x. We bring down our 5. X goes into x plus 1 times, so we distribute one more time, you get x plus 2. You subtract, these cancel, and there's that same 3 that we got before. So since that's our remainder, again, that verifies the fact that our quotient is x plus 1, and we have a remainder of 3 over our divisor. And so we see that both answers are the same, regardless of which method that we take a look at in this design. So I'll show another one. This will be example 2b. Again, I'm skipping the 2a's because we're not focusing on the factoring part. We want to find the quotient using reverse tabular and long division. So if we did reverse tabular method, right? So I need to know how many rows. So that's one more than I have with my exponent in the bottom, so I'm going to need 2 rows. And then for my columns, 3 minus 1 is 2. And so it's 1 more than that, so I'm going to need 3 columns. So we put a 3. So I'll design my box as such, right? 2 rows, three columns. So we put x minus 2 here on the side. We draw our arrows around the side. This is where our dividend is going to go. And so we put x to the third. We put 0x squared, so we have our quadratic. We have a 0x, and then a minus 4. So we put our x to the third into the box. We divide x to the third divided by x. We get x squared. We then multiply that x squared by negative 2, so you get negative 2x squared. Now we have to get 0x by all of these diagonals, so this is a negative 2x. This has to be a positive 2x squared, so if I add them together, I get 0x squared. So now 2x squared divided by x is going to be 2x. And then we multiply 2x times negative 2, we get negative 4x. Since this is also 0x, this has to be the opposite value, positive 4x. And we divide again, so we get plus 4. And then we multiply 4 times negative 2. This is that crucial point. We get negative 8. We were supposed to get negative 4. Since we did not get negative 4, that tells us that we have a remainder. So we put negative 8 plus r, and we subtract, or we add 8 to the other side. We find out that r is equal to 4. So that means the answer of this is x squared plus 2x plus 4 with a plus 4 over my divisor. Right? One more time, long division. We write our divisor, which is x minus 2. Remember, we have to account for all those missing family members. So we have to have x to the third plus 0x squared plus 0x, and then a minus 4. So x goes into x to the third, x squared times. So we get x to the third minus 2x squared. This cancels. So 0 minus negative 2. So we get 2x squared. We bring down our 0x. X goes into 2x squared, 2x times. Right? So we get 2x squared minus 4x. Put the parentheses. This cancels. And we get a 4x. We bring down the minus 4. And so x goes into this one positive 4 times. And so you end up with 4x minus 8. Put the parentheses. This cancels, negative 4 minus negative 8. And you get that remainder of 4. And again, that confirms our answer as the quotient of x squared plus 2x plus 4 with a remainder of 4 over our divisor, x minus 2. So these are the two methods, right? Long division versus reverse tabular. Again, like last time we studied these, you decide which way you want to go. and which way you don't want to go. So there are several exercise problems in here. We're going to skip exercises 1, 2, and 3. And so that gives us 4, 5, and 6. I'm going to show just one more of each. I'm going to show number 4 using reverse tabular, and I'm going to show number 7 with long division. I'll leave 5, 6, 8, and 9 alone. That way you see this worked out 3 times. And if you need additional help, just let me know. So number 4, right, reverse tabular method. So I know that I'm going to have one row. I'm sorry, not one row. One more than I do for my exponent at the bottom, which is a 1. So I'm going to have 2 rows, and then 2 minus 1 is 1, so we add 1. And that's going to give us 2 columns. So we'll draw our box. A 2-row, 2-column box. So here's our 2 rows. Here's our 2 columns. And so we'll put in our divisor of x minus 8. We'll put our dividend around the side. So that'll be x squared plus 4x and then plus 10. And so we put this x squared into here. And we divide x squared divided by x, and we get an x. So x times negative 8 is negative 8x. And so negative 8x plus something has to equal 4x. So that ends up being a 12x. So 12x divided by x is positive 12. And then the important box here is 12 times negative 8 is negative 96. So we'll put negative 96 plus r. And we move this over and we find out that r ends up equaling 106. That means our final answer for this one is going to be x plus 12. We had a remainder of 106. And we put that over our divisor of x minus 8. Alright, so again, that's the reverse tabular method. I'm going to show one more problem. I'm going to do it with long division. And so this will be number 7, long division method. So we'll end up writing x plus 6. We put x squared minus x minus 25. So x goes into x squared x times. So we distribute. You get x squared plus 6x. Close the parentheses. These cancel. Negative x minus 6 is negative 7x. We bring down the minus 25. X goes into negative 7x, negative 7 times. So you get negative 7x minus 42. Put the parentheses. This cancels. So negative 25 minus negative 42 is 17. That means my final answer is my quotient of x minus 7. And then I have to add 17 over my divisor for my remainder. So that is the long division method one more time. All right, so if you have any questions, let me know. Otherwise, you can do 5, 6, 8, and 9 on your own, and then start your problem set.